Bismillahirrahmanirrahim. My name is Ahmad Ishfaq Awan, and my topic is about model for human eye. So, first of all, we start up what is human eye. So, my topic is about a model for human eye movement consists of the closed loop system shown in figure. So, this is our closed loop system. So, by using this closed loop system, first of all we know about what this block diagram and closed loop system, what this saying. So object position, this will be as an input going to brain, and there will be some nanosecond delay. After this will be going to errors. When the system's input pass from these two errors, this will be going to nervous system, and there will be also some nanosecond delay. After this nervous system, the input going to muscles, which transfer function is K1, and after this will be going to I, which transfer function K2 over S plus A1 close bracket. So after this, the our output here is shown. By using this whole system, we applying an example here. So first of all, we assume that our input is curtain, to see curtain. So this is our input. This input going to brain, there will be delay. After this will be going to errors. By when this error doing, after this will be going to nervous system, muscles, eyes, and our output here is shown, which is to see curtain. So this is our output. So by using this system, we know about that muscle spindles position feedback. So their transfer function is K3. So this will be going to back to the errors, and this will be going to delay nervous system. So first of all, we know that what is muscle spindles position feedback in control system. Muscle spindles are skeletal muscle sensory receptors within the body of a muscle that primarily detect change in the length of this muscle contribution contribution to fine motor control and providing axial and limb position information to the control nervous system. So this is the brief explanation of muscle spindle position feedback, where transfer function is K3. So now second thing which we know about this muscle spindle rate feedback. So their transfer function is K4S over bracket S plus A2 close bracket. So we know about what is muscle spindle rate feedback. So this will be consist of intrafuel muscle fibers. So this muscle spindles consist of intrafuel muscle fibers enclosed in a sheath. Sheath mean here is spindle. They run parallel to the extrafuel muscle fibers and act as a receptors that provide information on muscles. So this will give information to the nervous system. This muscle spindle position feedback give information to the nervous system, and this muscle spindle rate feedback give information to the about to the muscles. So this is our explanation about movement of human eye, and this is our closed loop diagram. So I explained this what this closed loop system says and what this will be doing. So now come to the point is that first of all, when we know about model for human, we know about what what is human eye. Human eye, human eye is an organ that react to light and allow vision. So this thing react to light, and we see something as we previously used curtain example. So this eye react to curtain and allow to vision. Rod and cone cells in the retina allow conscious light perception and vision, including color differentiation and perception to of that. The eye is a part of the sensory nervous system. So we know about that there are movement in the movement of eye referred to as an extra ocular muscles. Four muscles control the movement of eye in four directions. So the movement of this eye organ is uh, four types. One type is to see upward, to see downward, to see left or right. So this is the movement of our muscle. The remaining two muscles control the adjustment in gaze direction involved in head movement. So there are six types. I am repeating that there are six types. One is moving upward, downward, left or right. So the other two is related to the mind movement related to the eye. So this is actually related to the gaze direction. The four muscle controlling standard eye movement are the superior. Here is superior. Second one is inferior. Third one is oblique. Oblique. So I am explaining that there are six types: superior rectus, superior oblique, medial rectus, inferior rectus, rectus, inferior oblique. So there are six types which we explain here. So this is the brief introduction about the model for human eye. So now come to the point is that so this is our related which we explain here. So there is the solution of this problem is here. The equivalent transfer function toward function is gs k1 k2. So this is our equivalent forward transfer function. So this comes from this k1 plus k2 divided by s plus a1. So this is our forward transfer function which is represented by g of s. So the second thing which we know about this, the equivalent feedback function is h of s. So this comes from this k3 muscle spindle position feedback transfer function plus muscle spindle rate feedback k4s divided by s plus a2 close bracket. So this is our h of s coming from this diagram. So now hence the closed loop transfer function is by using this formula we put value of gs which is equal to k1 plus k2 divided by s bracket s plus a1 close bracket. So this is our g of s, and now by putting the value of g of s in the formula and by putting the value of h of s which is equal to k3 plus k4 s plus a2, by putting this we get this. So this is our result by which we derive from by using transfer functions formula, closed loop transfer function. So this is actually comes from by using this diagram, and in this diagram we remember and understand this closed loop system by seeing the curtain example. So next, which is related to simulation in MATLAB. So here is num. Actually num is numerator which is equal to 2 cross 10 power minus 0.15 space 0. So this is our numerator, then which represent denominator, which value here. So sims transfer function num comma done. So steps sims. So this is our output. So by this gets after some time we use Octave Online software. So by putting these values we get this. So later we discuss this. So this is our simulation in Simulink. So step, transfer function, scope. By here we can see our result. So this is our simulation, and there will be the output of this Simulink. So we can compare this one and this output. There is no difference between this output of Simulink and in output of MATLAB. So there is no difference. This is our conclusion. So come to the point is that simulation. So now we performing this on Octave Online. So by seeing this is our actually this is our result. So we solve this again, Octave Online. So here we write our code, which is equal we write our code num equal to bracket 2 cross 10 minus 10 raised to power minus 0.15 space 0 bracket closed. 0.15. So this is our, now come to the second, which is equal to 10 equal to bracket 0.13131 bracket close semicolon. So this is our 10 sims equal to transfer function num comma 10 bracket close. So here we see that our transfer function is here. So we get a graph from this. By seeing graph we use some values of time. So we give times value here, t is equal to 0 colon 0.1 colon 10. So this is the values of time. So enter. So here the values. So we can see our graph. So we put y is equal to step sims comma t bracket close semicolon. So plot, which is equal plot close bracket t comma y. So here is, by using this we can see our graph. So our graph shows our input output, which is equal by using time 0 colon 0.1 10. So same as our we mentioned here. So by using this software we can draw our output of this. So reference of these slides are we write here. So here are the reference of we can use from this. Okay, Allah Hafiz.